So our task is to build the machine learning workflow using KNIME to forecast price of the car. Ini ya ikut kelas Python saya dia dah buat. Cuma saya nak add another feature. Okay, there might be some sort of little bit, I can say, surprise element that we are going to check here. Okay, surprise element. Okay, so now I have input. Ini adalah saya punya label ataupun saya punya response price. Okay. And then I have all these candidate. Okay, sebelum dia dijadikan input, age, kilometer, HP, metallic color, okay, automatic CC and field type. Okay, so basically we call them as a candidate. Okay, so the potential input, the input candidate. Okay, kita panggil dia candidate. So kenapa dia candidate? Sebab kita kena buat pilihan which input values that is suitable to predict the price. Okay, to predict the price. Okay, and also you see here some inputs, some of them they are not numeric, not some, one of them, field type here. Okay, so saya tak boleh sewenang-wenangnya masukkan. We cannot simply input petrol as the input. No, not do that. So there must be a transformation that we have to be done. Okay, ini kita panggil transformation later on into the input of this row or this column. Okay, but some inputs you see metallic color and automatic. Yeah, so input ni satu means metallic color. The car is a metallic color. Zero mean non-metallic color. Okay, so they are considered as a discrete value. Okay, automatic, zero is not automatic, one is automatic car. Okay, one is automatic car. Okay, CC can be considered as, boleh dikatakan, saya rasa dia more into apa kita panggil, dia more into, boleh juga saya kata dia continuous, tapi boleh juga saya katakan dia discrete ya. Sebab dia mesti consist 2000 ya, 1.8 1800, okay, something like that. Okay, so it's most important for us to understand. So ada satu lagi variable is number of door and weight kalau tak silap. Okay, ada a few lagi variable. Okay, let's import the data set. Okay, so the name of the data set apa? The name of the data set is car price clean, if I'm not mistaken. Okay, car price clean. Cuba tengok car price clean ni padam lah ya, sekejap ya. So car price clean ya, I already clean the data, so we don't have to waste time, a lot of time to clean this data anymore. Okay, so import. Oops, sorry. Okay, so CSV file, so copy je yang ada ni. Copy je yang ni. Okay, and then input it. Okay, ini senanglah input ni. Okay, so mana tadi? New, oh, no. Mana dia? Okay, ni. Okay, alright. So dekat sini kita buat a little bit transformation. I want to transform it here or later. I think I want to do the transformation here. Okay, so saya nak tukarkan yang ni ya, metallic color dengan automatic ni supaya dia menjadi string. Okay, metallic color convert into string, automatic pun convert into string. Kenapa? Sebab dia adalah discrete value. If I'm not using a number, can I use yes or no? Boleh kan? So maksudnya bila metallic color 1, yes. 0, no. So the same representation here, I define them as a string. Okay, kenapa? Sebab nanti I want to perform some sort of other things that I can show to you. Okay, satu lagi adalah doors ya. Doors, pintu. Sebab pintu 1, 2, 3 dia tak ada 1.1 pintu. Yeah, so we have to change that. Okay, we change the door. Yeah, and also weight. Yeah, weight tak payah. Sorry. Weight tak payah. Weight is continuous. Yeah, the rest is considered as continuous. Okay, and then click apply and okay. Yeah. Ini kita nak buat sedikit feature selection. Ini kita panggil sebagai feature selection. Okay, kenapa dia? Okay, you see here. Okay, so ini feature selection. Maksudnya saya nak pilih input yang mempengaruhi change of the price. Okay, alright. Okay, so okay, tengok data. Okay, betul. Price integer, age integer, kilometer, fuel type, horsepower, metallic, color. Okay, alright. Okay, okay, nice. Okay, nice. Okay, sekarang ni I want to study all the numerics value. Okay, maksudnya selain daripada door, apalagi automatics and also metallic color dan juga fuel type. I want to see the correlation. Ada tak correlation of this continuous numeric number with price? Okay, so I can use linear correlation. Linear correlation nodes. Okay, so linear correlation nodes. Okay, cuba tuan-tuan dan perempuan ni. Okay, drag it. Okay, so please remove this data type with string variable. Okay, all the string data type kita exclude because X string we cannot use correlation to define the relationship. Okay, we cannot use that. Okay, click apply, and then click OK. Right click and execute. Saya rasa tak perlu view. Yang paling penting adalah yang ni. Correlation measure ni. Sorry. Oh, belum run. Okay. Okay, run and then correlation measure. Wah, kalau tengok macam ni macam pening juga Okay. So I want to see the price here. Anything that correlated with the price. I don't want to care correlation between age and kilometer. I don't want to care that. The most important thing, I want to care about what the relationship between age and price, kilometer and price. Is there any change of the price, the age of the car? Will change the price of the car. Okay, so we want to see that. Okay, so you see here there is a number of correlation, tapi macam kurang kemas. How about we sort that correlation? Pertama, kita gunakan column filter supaya saya boleh filter price sahaja. Okay, so saya filter price sahaja. So gunakan row filter. Okay, row filter. So type ROW filter. Okay, this one is the things that we learned before. Still remember in basic, yeah. So row filter. Some of this step might be not necessary. It depend on you. Untuk saya nak view dia cantik sikit. Okay, I want to view it properly. So I want to ni, and then the first column name. Okay, so first column name ni saya nak ambil price sahaja. Okay, the condition, the column to test is only the first column name. Kenapa? Sebab you see here in this data set, in this correlation measure. Okay, so the first column, I want to see only the price. Okay, ini yang kita nak ambil. Okay, so when I run this, so we will see this value. Okay, this one. Okay, correlation between price and age, kilometer, blah, blah, blah. Okay, so saya nak rankkan dia pula. Boleh tak saya rankkan this correlation? Saya nak sortkan dia. Okay, from low to the. Okay, in correlation. Okay, have I give the lecture about correlation before? Mungkin belum. Oh, mana pula? Dia ada satu slide on correlation. Allow me to share that. Oops. Tak ada Okay, sekejap ya. I open the new slide. Sekejap ya. Dia ada dekat satu lagi slide. Terlalu banyak slide ni. Okay, wait. Allow me to open the slide. Yeah. Okay, this one. Yeah, this one. Yeah. Okay, this correlation slide. Okay. Okay, let me talk about the correlation first. So this one's supposed to be oh, sebab saya buka ni. Okay, dia ada dua tab. Okay, so you see here the correlation, dia bukan R squared. Okay, correlation is different things. Okay, so the value of correlation is range between -1 into 1. Okay, so if it's towards -1, maksudnya dia dia ada negative correlation, means that by increasing the value of X will decrease the value of Y. Itu maksudnya. Okay, if there is no correlation, means that I cannot say, I cannot define the relationship here. Okay, change of X, I'm not sure what is the change of Y here. Okay, we cannot say any positive or negative correlation, means that towards 0, there is no correlation. And if it is towards +1, means that it's toward a strong positive correlation. The bigger the X value, the bigger the Y value. That is meant by like positive correlation. Okay, so in this case, okay, in the case, okay, this one, I want to rearrange it. So the most negative correlation, I want it to be on the top. The most positive correlation, I want to be on the bottom. So you can do any vice versa, doesn't matter. So use a sorter node. Sorter node. Okay, type sorter, then click, drag the sorter here. Okay. So connect this sorter node and then use maybe ascending and depend on the correlation value. Okay, choose correlation value and use descending, ascending or descending doesn't matter. So means that the top one with the strong negative correlation. Okay, so from here I can have the hypothesis mentioning that the age is the factors that highly affecting the change of the price. Because what you see, 0 is the midpoint. Even if you see the price and weight, itu nanti kita cerita price and weight. Okay, so you see the correlation of age is -0.87, is almost -1. Okay, maksudnya perubahan umur kereta tu. Okay, if you want to sell the second-hand price, the car price, right? So the higher the age, the lower the price. Okay, and followed by mileage. KM is a mileage. Okay, and also CC contribute into the positive correlation. The higher the CC, the higher the price, of course. But horsepower is more predominant here. Okay, but weight, tengok weight ni. Semakin berat kereta tu, semakin mahal kereta tu. Is it relevant? Inilah yang kita panggil sebagai our intuition. Okay, whether weight can be used to predict the price. Okay, by value, by correlation value, oh, I can use. Ini bagi someone yang, itu yang saya tak suka automate ML tu. Ya, auto ML tu. Kalau auto ML dia ambil je ni. Dia kata, by I'm set, okay, any correlation greater than this, oh, saya ambil. So, by intuition, I cannot add weight, but I can add age, kilometer, and also HP. CC ni terlalu kecil, less than 0.2, so I don't want to add this. So I want age, kilometer, and HP. Ya, menarik ya, okay? Okay, itu untuk numerical variables. Okay, itu untuk numerical variables. How about categorical variables dan juga apa nama tadi? Dan juga discrete variable. But all the discrete variable we already changed into apa namanya? Already changed into categorical variable. Sorry. Okay. So how do we do that? So I teach you how to use a conditional box plot. Okay, to define that. Okay. So let's see. Even we can visualize it. Okay, katakanlah saya gunakan scatter matrix. Ingat tak scatter matrix yang saya pernah beritahu dulu? So you use scatter matrix to confirm that linear relationship. Okay, so double click here. Mungkin tak sesuai ambil dari sini. I think row filter. I think row filter lebih. Row filter lebih sesuai. Wait ya. From here, I guess the data from here is much better. Okay. Ada something kat sini. Oh, dia ambil value lain ni. Boleh. Delete. Okay. Okay, kita plotkan yang ni. Okay, and then apply all the category, all the numeric values kat sini. Okay, so dia akan consider all the numeric values here. Okay, so price and age. Okay, contoh saya nak add apa tadi? CC, HP. Okay, so we also can visualize it. So kalau nampak kat sini, CC and HP, sebab tu saya cakap CC is more likely into discrete variable, tetapi data ni terlalu proper lah, sebab kalau yang ni ada pula trend dia. So that's why I just use this as a continuous ya. HP, yes I can use, dia nampak ada sedikit trend, sorry kalau kecil ya. So dia ada sedikit trend lah dekat situ, to show is a positive correlation with price ya. Sama juga kalau kilometer, dia negative correlation. Age memang cantik tau. Ini kita jangan tengok lah, ini price and price, perfect correlation. Okay, so ini by visual. Okay, so another method is for continuous for categorical variable. So here I use yes.
Scatter matrix. Can you open the before?
Okay.
Yeah.
For the setting scatter matrix. Okay. So the setting is dia tak banyak. Ini saja. Dia tak ada banyak parameters yang kita adjust. Yeah. Okay. You got it already? Okay, and you open it and then go to scatter matrix here.
Okay,
so here,
okay.
Yeah. So here you can adjust the parameters. For example, I want to add maybe CC. Yeah, you want to take a look into a CC. So here the CC will be added here. So CC and price, what is the correlation? So you can see. Okay, so this is more like a scatter plot. Okay, right. Can I? Okay. Okay, so the next thing is to evaluate the categorical variable. So here we use a conditional box plot. Okay, search for view. Okay, go to view here. Okay, and then go to JavaScript. Okay, and then search for conditional box plot. Okay, conditional box plot. Okay, so kita akan gunakan satu box plot ni to do 3 tests. Okay, kita akan gunakan satu box plot. Okay, so connect it, and then we want to determine category column. Okay, ini adalah, for example, I want to see whether the change of the fuel affecting the price. Okay, affecting the price. So itu yang saya nak observe dahulu. Okay, and then ini kita select price because I want to test is based on price, and then that price will also become a column. Okay, kategori adalah yang paksi X tu. Okay, what category that we want to select here. Okay, and then click apply, right click and open view. Okay, so we will get this. Okay, we will have this figure. Okay, so what I can show here is, I think we discussed about this before. I forget, mungkin saya terlupa. Macam ada sebut, ya, mungkin kelas lain. Ya. So, can I say that the price for the diesel car is more expensive than CNG? Boleh kan? Kalau kita tengok ini adalah range, ya. Maksudnya untuk diesel, the minimum price of the car started from 4350 and the highest will be more than 30,000. Itu adalah range. But when I talk about CNG, the range of the price is only between 5250 until 14,000, something like that. Okay, so I can say that if I buy the car based on fuel, it will affect the price. Maybe the price, if I choose diesel, it can be as expensive as more than 30,000 and as cheap 4,000 plus. Dia boleh jadi yang paling murah, dia boleh jadi paling mahal. So I can say this is definitely affecting the price change of the car. Okay, so let's test another categorical variables, which is metallic color. Okay, metallic color over here. Okay, so if metallic color, click apply, right click and execute an open view. I can say, yeah, there is a change, tapi ada juga yang paling, I can say almost similar range lah. Okay, we can say it's almost similar range. Okay, if non-metallic, the price is expensive here, but it can say, you see the presence of this median also lebih kurang sama dia punya location of this median. Okay, maybe metallic color doesn't affect. Okay, maybe. Okay, so in this case kita tak include dia dahulu. Okay, we tak include. Kita boleh katakanlah lain kali nak test, mungkin dia mempengaruhi. No worry, we always can add it together. Okay, we always can add it together. Okay, so in this case kita katakan dulu metallic color tidak mempengaruhi. How about another attribute which is apa dia? Automatic. Sama ada dia automatic atau tidak. Klik apply. Okay. Right click, execute and open view. Yes. Tapi kalau saya pun ingat kereta automatic mungkin lagi mahal lah. Second hand price dia. Wah, tak juga. Okay. So non-automatic is more expensive. Okay, as a second value car. Okay, so this is the data that you can see here. Okay, the data. Okay, so I can say that the automatic, the transmission, the transmission lah, sama ada dia automatic atau bukan. Okay, affect the change of the price. Okay, affect the change of the price. The last one is very strange. Pintu. Wah, jumlah pintu boleh mempengaruhi harga kereta. Maybe let's take a look. Wah, nampak dari sini, ya. Okay, pintu kereta with 2 pintu memang lagi murah compare to kereta yang ada 5 pintu. But do you think this data is relevant to be added? Sama juga dengan case weight tadi. Okay, jumlah pintu sometimes by logic. Okay, but the proportion, the number of car with 2 doors here is very small. Okay, so from here we cannot justify anything actually. Okay, and it's irrelevant. Sebagai pembeli, saya mau beli kereta, wah, is it based on the pintu, jenis pintu ke, berapa biji pintu kereta ni, ataupun berapa berat kereta, so tak ada kan, so we cannot add this as the input. Okay, clear on that ya. Okay, so now I have 5 berapa 5 okay, nanti kita susun lah. I think from here we choose 3 just now, I guess. Okay, from here we choose H, kilometer, and horsepower. Horsepower 3. Here we add another 2. Another fuel type. Apa tadi? We choose fuel type automatics. Okay, so we add another 2 here. Okay, fuel type mempengaruhi, automatic mempengaruhi. Okay. All right. So another things that we want to investigate. Okay, ini penting. Okay, individual variable of the price itself. Okay, kenapa dia penting? Sebab dia benda yang kita nak predict nanti. Itu yang penting. So, I have to perform univariate analysis. Univariate is something that focusing on individual variables. Itu kita panggil univariate. Okay, so I have to perform univariate analysis into the price. So, one of the things that I can do is to investigate, okay, whether there is a outliers. What is the distribution of the price? Kat sini. Okay, so I can use apa agak-agaknya tuan-tuan perempuan. Okay, if I want to determine the distribution of the price. Any answers? Any answers here? Apa dia punya notes yang kita boleh pakai? I want to see the distribution. Okay, histogram. Okay, correct. Okay, histogram. Alright, kita gunakan histogram, guna yang JavaScript punya. Yes. Okay. Alright, so connect it. Okay. And then the things that we want to find the histogram is the price. And saya nak tengok dia punya occurrence count. Okay. Search for histogram and then select price. Okay. Jangan klik ni, nanti hang. And then go to the binding. We adjust the number of the bins. Okay. Katakanlah ini kita tukar 20. I like 20. Okay. And then kita set borders, bin naming ni kita set borders, okay, and then kita force that borders value to be in integer. Okay, ini cantik sikit. Okay, so in histogram, in the binding punya tab, select number of bins 20, choose bin naming borders, and force that value into integer bounds. Okay, supaya dia punya boundary nanti dalam bentuk integer instead of decimal places. Okay, and then click apply. Okay, execute and open view. Okay.
Sorry, Doktor. Saya
yes.
tertinggal sekejap.
Okay.
Please.
Which one?
Yang histogram punya setting.
Okay. Histogram, which part? Is it? Okay, make sure you check price here. Okay, and then select occurrence count. Yang ni dia tak ada effect lah, ini tak ada apa. Okay. Alright, and then go to the binding. Binding is important. Okay, make sure fix number of bins. So I fix 20 and make sure all of them are in equal width. So ini by default lah. Okay. Choose borders and force it as integer. Itu saja.
Alright, got it. Thank you.
Alright. Okay, click and then right click and then histogram view. Okay, so this is the view that I get from this histogram. Okay. So bagi yang pernah ikut machine learning, okay, dia tahu apa yang saya nak cakap selepas ni. So my model is good to predict the price within this range. Maksudnya model saya dia bagus tau, with a less error if they try to predict within this. Between 7,000 between 5,758 until 14,000 plus. So ini yang model saya bagus untuk predict, okay? Because the density of the data is distributed here. Okay, and if it is going towards on the right side, I can say this is a histogram that is scattered, that is skewed to the right. Okay, dekat sini nampak tak? There might be a possible of outliers. Nampak tak? The value of the car, that price more than 30,000 ada 2, ada 1 kat sini, and then kosong kat sini. So ini boleh dikatakan some sort of outliers. Okay, still remember, to show the outliers, I can use another graph we call as a box plot. Conditional box plot to show the relationship. Okay, box plot is to show the presence of outliers. All right, so connect that, search for the box plot, and then kita nak box plot apa Kita nak box plot price sahaja. Okay, only choose price. Okay, only choose price and then click apply. Right click, execute and open view. Okay, so now we have this. Okay. Right. So a few things that I can see here. First, there is a outliers over here. Okay, ini adalah extreme outliers. Sebenarnya ini dah consider outliers kan. But I focus on the extreme outliers. Kalau saya delete terlalu banyak, so you see almost half of the data set will be deleted, and it reduces the strength of my model. So I don't want to delete too much on the data set. Okay, so what I can do is maybe I can delete this. So ini adalah data yang mewakili yang outliers kat sini tadi. Okay, this is the data. But can you see which data that can, dekat mana ni tadi? Kereta apa? Boleh tak saya jawab? What car, that price, what type of fuel? So if you see, mana tadi we want to see the, we can see it here. Okay, conditional box plot. Cuba check on fuel type. Okay, so nampak tak some sort of facts here? So kereta yang berharga, the things that create outliers here adalah kereta yang engine dia diesel. Sepatutnya I can say that if the price of the car is petrol and diesel, sepatutnya dia lebih kurang sama harga. I can say that. Tapi it can generate as a outliers here. Okay, so some sort of this thing that can, maybe we also can check metallic color ataupun automatic car. Ada tak relationship ni? Betul juga. Mungkin automatic car, you see the non-automatic car and non-automatic. So you see these are the things that create outliers. So maksudnya data yang ada outliers adalah data yang keretanya fuel which is diesel and also for non-automatic car. So ini akan jadi outliers here. These are the car that can consider as outliers. Okay, so kereta yang mahal, yang sangat mahal dalam grup ni, I can say the type of fuel is diesel and then it's a non-automatic. Okay, so mungkin kalau di Sarawak kita banyak guna Hilux. Okay, and then kebanyakannya guna manual. Okay, ada juga guna auto. Tapi if the use of the Hilux is for, kalau tempat saya memang untuk kelapa sawit lah. Okay, alright. So people willing to buy, if they purchase the second hand car, they will buy that Hilux with manual instead of automatic. Okay, and then the price of the manual is priced higher for this range of car. And you see the Hilux kebanyakan dia punya oil adalah diesel. Okay, ini lebih kurang yang ni lah. Okay. Oh yeah. Oh, Catherine is from Sarawak. Yes, I'm Sarawak. I think my voice is slang memang. Okay, I'm Sarawak. Okay. Yeah, I'm Sarawak. So you see the car there. So depend on this. So this is some things that I can relate to this example. Okay. Yeah. All right. Okay. All right. So let's continue. Yeah. Let's continue. So how to remove that? Apa nama tu? How to remove that? What we call outliers. So kita ada outliers punya node. Okay. So type outliers kat situ. Okay. Numeric outliers. Okay, dia ada numeric outliers. Okay. All right, so connect it here. Oops. So we want to perform a treatment. Okay, kita nak buat treatment sikit data ni. We want to delete that outliers. Okay, we want to delete that outliers. So based on what? Based on price. So select only price. Okay, make sure you select the price. Okay, so setting ni kita kena tengok apa yang saya buat ya. Okay, so kita biarkan dulu interquartile range multiplier ni as 1.5. Biarkan dia dulu. Okay, so replace, okay, apply to outlier, all outliers. So kita boleh tengok below upper bound. So kalau kita tengok tadi graph yang kita ada. Okay, so upper bound ni yang saya nak delete. Bawah ni tak ada. So in this case, maybe it's safe for me to choose upper bound saja. Upper bound. Apply to outliers above upper bound. Okay, so upper bound adalah yang ni. Ni upper bound. So nanti dia consider to delete all this. Tapi as I mentioned earlier, saya nak delete yang 3 ni saja. So how do we do that? Okay, later I will show to you. And then treatment option. So kita kata kita nak remove outliers row. Okay, jangan non outliers pula. Okay, kita nak remove outliers row. Okay, click apply. And then right click and execute. Copy back this box plot and try to visualize pula data yang tak ada outliers ni. From where? Let me check. Treated table, yes, the treated table. Okay, the treated table. So right click and open view. Okay, so cuba kita tengok perbezaan dua table ni. Okay, so tadi, you still remember, now the new upper value here 154.500. So ini dia delete semua tau. Banyak ni. Dia delete banyak. Okay. Saya kata nak delete atas ni tadi. So, one of the important facts here adalah K factor tadi. Okay. Yang ni. Multiplier ni. Okay. Interquartile range ni. Okay. IQR kita panggil. So, what is mean by IQR? Ada yang saya rasa dah tahulah. So, interquartile range adalah ini from here. So they want to determine what is the maximum. Ini adalah 1.5 times ini. Ini adalah interquartile range. So 11,950 minus 5450 times 1.5 will give me no. 1.5 times, okay. 11950 plus nilai yang kita tolak ni tadi darab 1.5 will give me this value. So that's how we get this upper bound. So more than upper bounds they akan consider outliers. So one of the process, macam mana saya nak fokus kepada sini je. So I have to increase that. Instead of 1.5 saya katakan naikkan par ni. So that I will remove that. So I already calculated that the value is 4. Okay, the value is 4. So it indicate that we delete top 1% of the data set. So cuba kita tengok. Okay, run it. So you see, now cuba tengok original. Ni entry. Oops, sorry. Sekejap. Padam dulu. Okay, ini padam dulu. So I view this one. Okay, ini adalah original with the apa nama tu? With the outliers. So this one we already remove the top outliers. Okay. So if let's say, so nampak tak dekat sini 25,000. So ada beberapa data yang dia tak ambil. So mungkin 4 tak cukup. Okay. So maybe I need to change it into 5, I guess. 5. Okay, 5. Alright, so run it again. Ini baru dia ambil semua data tu. Okay, so you see here, all this data here already been captured. So yang dia remove adalah yang top one. Ini yang dia dah remove. Okay, so this is the data that we are going to proceed. Okay, for the machine learning. Oh, sekarang mau pukul 11, can we extend 15 more minutes? Boleh tak? At least kita boleh habiskan ni, besok kita relax sikit. Boleh ya? Can, everyone, boleh? Okay, Cindy boleh? Okay, Kevin, boleh ya? Santai je lah, ya, santai, relax, ya, relax. Okay, alright. Okay, allow me 15 more minutes, ya. Okay, so now the data been treated. Okay, so that data containing 1428 rows. Okay, because originally data tu total number of rows dia, kalau kita tengok ini tolak 1 1434. Okay, sebab dia start dari 0 lah. Okay, so the total number of the row is 1434. So and then we have reduce the dimension, reduce the size of data because we already removed the outliers. So this is the ini yang masih no, we cannot depend on this. We have to check here. Okay, sebab dia mungkin number of row tu dia tukar lain. So total number of row dia 1428. Okay, ini yang the recent one. Okay, so sikit lah amount yang kita delete tadi. Okay, so next what do we do? Okay, check treated table. So from now on we will take this data. So kita nak deal with this. Yeah, kita nak deal with a few variables tadi. So I know that I want to include automatic, metallic color. Metallic color tak nak. Okay, CC saya tak nak juga tadi. Doors tak nak, weight tak nak. Okay, horsepower yes I want. Tapi automatic and metallic color ni, I want to rechange it again into number. So that I don't have to perform any transformation from categorical into dummy variable. So I want to avoid that. Okay, so in order to avoid that, saya tukar dia dalam bentuk nombor lagi. Kalau tadi saya tak boleh guna straight nombor sebab I want to plot the scatter plot, plot the conditional box plot ni. So in this case, I will convert automatic and metallic color into a number back. Okay, so use string to number. String to number, drag it here, and then connect the node here. Okay, so variable mana? Okay, so dia akan only choose, okay, the one that in string form lah. So kita choose yang kita berminat sahaja, which is metallic color and also automatic. Metallic color saya tak nak, tapi just change it into the original condition. Mungkin lain kali saya nak test whether this metallic color can improvise the model or not. Okay, can improvise a model or not. Okay, and then this one we change into integer. Okay, we change to integer and then click apply. Okay, right click and execute. Okay, right click and execute. So you see all the data right now, metallic color and automatic already been in integer. So lain kali saya boleh masukkan input dia 1 atau 0. Okay, I can input that. Okay. Okay, the next thing that I have to deal is categorical variables. Okay, so I have petrol, I have diesel, I have CNG. Okay, but I cannot input this as a value because it's not a number. So machine learning, everything must be a number. Okay, the text have to transform into a number. Okay, so in order to do that transformation, so I have to apply a dummy variable. Okay, so what does it mean? So I have to create a few dummy variables from this variable. So from these matrices, okay, I convert them into a form of, we call it's not a tensor. Ada orang cakap dia tensor because it's already in the two-dimensional form of data representation, but we call it as a binary transformation. Okay, why is binary? Because you see, I use only the binary number here. Binary number is only 0 and 1. Tak ada 3, yeah. So the binary number here. So if let's say I create this dummy variable, so this coded indicate that this is a petrol. Okay, fuel type petrol 1, the rest must be 0, then this is petrol. Kalau 1 for diesel, so 0 for the others, so that is a what do you call diesel. Okay, if fuel type CNG dummy is 1 and then the rest is 0, so then the fuel type for that particular row is a CNG. So ini kita panggil sebagai transformation of categorical variable into dummy variable, and that dummy variable dia dalam bentuk binary number. Okay, so how do we do that? Okay, we use one node we call as one to many. Okay, we perform the transformation into that particular column. Okay, so we use one to many. Okay, one to many. Okay, one to many. So double click on this. Mana pula dia? Oh, saya ada 2 pula. Satu cukup. Okay, one to many. Okay, and then right click on this. Configure. Door tak payah, tak ada kaitan dengan door. Door kita tak mahu tadi. And then click apply. Field type. Make sure this is only a field type. Click apply. Right click and execute. Okay. So let's take a look into this process data. Okay. So you see, previously ini field type dia dalam bentuk this one. Okay, fuel type dia ada diesel. So sekarang ni dia create these 3 dummy variables. So if the fuel type is diesel, so you see the coded, the binary code is 100 for these 3 dummy variables. Kalau dia petrol, so 010. So mean that 0 for diesel, petrol 1, and CNG 0. Okay, so next time we have to bring these 3 variables because we believe that the fuel type is affecting the price, so kita kena bawa. Tetapi as a data, okay, we have to remove one of the variable here. Okay, we have to remove one of the variable here. Okay, later I will talk about that. So sekarang ni saya nak filter kolom untuk saya predict the price tadi, which is go to the next stage. Okay, to normalize and also partitioning the data set. Okay, so how do we do that? So we use column filter. Search for column filter. Okay, column filter. So nampak tak bila column filter ni? Kenapa? Sebab sekarang data dah almost ready. Okay, sekarang ni saya nak pilih variable yang I want to use to go to the next stage. Okay, so what I want to do is double click on the column filter. Okay, and then choose all the variable, go to the next stage. So kita nak predict price, right? And I want to predict price based on age, based on kilometer. Field type ni bawa tak? Cuba tengok. Field type ni perlu bawa tak? I want to train the model after this. Ada tak jawapan ke sudah pening-pening? Ya, bawa. Okey, ada yang kata bawa, ada yang kata no, tak perlu. Okey. Alright, tak perlu. Okey? Ya, sebab one to many. Okey, kita tak perlu sebab when we want to train the model, kita tak boleh gunakan string data. Everything kena guna numeric data. Okay, sebab tu kita dah tukar dia. Maksudnya kita ada diesel, petrol, and CNG. Alright, good. Okay, semua masih cergas lagi. Terbaik. Okay, mantap. Okay, mana tadi? Okay, so tadi I want to predict based on automatic juga, betul tak? Okay, I want to predict based on automatic. And then I also want to predict based on the field type, which is these three variable, right? Okay, HP, betul, HP lupa bawa. HP pun lupa bawa tadi. Okay, and then based on these three type, diesel, petrol, and CNG. Okay, di sini ada sedikit yang saya nak bagi tahu. Saya tak mau bawa CNG. Okay, ada orang cakap, oh bawa je lah semua. Okay, ada juga buat macam tu. But I want to minimize the problem here. What's the problem that have possible, maksudnya the possible problem that could happen is, let's take a look into this data. Okay, kita nak avoid dummy track. Maksudnya, what happen if everything is 000? Apa jenis minyak dia? Tak ada kan? So, itu dummy track. Okay, tetapi if both 00, it indicate the, okay, contoh ya, fuel type petrol 0, diesel 0. So itu adalah representing CNG. Itu satu problem yang kita boleh minimize. Okay, tapi ada juga yang cakap, what happen if 111? Okay, so itu salah satu problem that we cannot. Okay, so that's why the reason is to minimize the track. Okay, so at least we minimize one of it. Okay, satu lagi adalah multi-collinearity effect. Bermaksud, contoh kalau kita tengok di sini ya. If one, then both of these 0. Maksudnya ini akan correlated to each other. Okay, sama juga dengan macam mana ya. Dia ada case yang contoh I cannot think of it. There's some example that can show collinearity. Yeah? Speed and velocity. Speed and acceleration. Cannot do that. Tak apa, itu nanti kita try. I try to find the right example, okay, to mention about this. Yeah, okay. Yeah, circularity in Excel. Yeah, it's more like multi-collinearity. Maksudnya dua variable tu dia always correlated. Itu yang saya maksudkan. Okay, so means that kalau kalau ini satu, dua-dua ni mesti kosong. Itu maksudnya multi-collinearity. Okay, so for example, there is a possible linear relationship between speed and acceleration lah. So the faster you run, of course, your acceleration is not juga. The faster you run, yes, okay. So the faster you run, okay, so the time that you reach there will be shorter. So nampak tak ada linear relationship dekat situ. Okay, but in input kita tak boleh ada. Kalau boleh, we want to minimize ada dua variable yang correlated to each other. Okay, itu yang kita try to minimize this effect because some algorithm they are very sensitive to this effect. Okay, naive Bayes, for example. Okay, we talk about that in the next lesson, that one. Okay, so we remove that, so kita tak perlu CNG. Why my decision CNG? Because CNG jumlah paling kecil kat sini. Okay, and if you want to check, you always can use pie chart. Use a pie chart. So drag it here. So use a pie chart. Okay, so look for the field type. Click apply and then right click, execute an open view. So you see CNG baru 17, which is very small. I can view in the term of percentage. So berapa persen ni? Okay, it's very small lah. Okay, very small. The percentage is very small there. Okay, compared to the others. All right. So I remove CNG lah. Okay, I remove CNG. Okay, so I filter the column. Okay. All right. So now I have input satu. Oh, metallic color saya tak nak tadi. Metallic color saya tak nak kan. I don't want the metallic. Kenapa semua? Alamak. Oh, saya lupa tadi. Age, kilometer, fuel type no need, horsepower yes, automatic yes, diesel and petrol yes. This is correct. Okay, execute. Okay, so now I have this filter table. Okay, so next adalah what next? Okay, can I just, now data is ready, can I just straightforward and train the algorithm? Okay, so what's the answer bagi yang ikut machine learning class? Apa yang saya buat selepas ni after I ready? Can I just go and train the algorithm? Can I do that? Any suggestion here? Okay, any suggestion here? Yeah. What should I do? Okay. All right. Partitioning. Okay. Good try. Okay. Partitioning. Yes, one of it. Okay. Yes, I can do the partitioning straight away. Tetapi ada reason kenapa saya tak buat. You see the data set here. Take a look into the input features. Okay, kita tengok into dia punya input feature. Price ni adalah dia punya response. So you see all the input features kat sini, the size, the magnitude of the data point are not similar. The dimension, the unit, price pula, age 23, ya, kilometer besar dia punya range. Ya, horsepower this. Kan, automatic diesel and petrol macam ni pula dia punya. So the dimension is not consistent. Okay. Yes, correct. So the answer is standardization, or another word we call as a normalization. Okay. Can I directly train the algorithm menggunakan data ni? Boleh. Even the model also can predict the price. Tetapi the interpretation of the data will not be correct. I believe that if we are not normalize this, dia akan bagi kilometer ni sangat tinggi dia punya factor. Okay, dia punya coefficient sebab dia besar. So we cannot decide based on that. So we have to normalize. So next we do the normalization. Okay, look for the normalizer. Okay, normalizer. Okay, drag normalizer here and then perform the normalization. So once I perform the normalization, so you will see the range of these inputs will be almost similar lah. Not almost similar, maksudnya dia dalam standard range. Dia taklah terlalu besar, dia taklah terlalu kecil. Dia dalam standard. So how do I define that standard? So ada 3 mode dekat sini. Okay, dalam saya punya machine, dalam saya punya ebook tu ada cerita semua benda ni. Okay, so if you choose the normalizer, so which one that you want to normalize? jangan normalizekan price. Nanti kalau normalizekan price, nanti kita denormalizekan balik. So, buat 2-3 kerja. So, jangan normalize price ni. Okay, biar dia, keluarkan dia price. Only normalize the input values. Okay, so saya ada min-max normalization. Okay, even I can use z-score normalization. Ya, normalization by decimal. Katakanlah saya gunakan min-max. Okay, ini you can check, you can choose other range. Contoh minimum value saya nak -1 until 1 pun boleh. In this case saya nak 0 to 1 pun boleh. Okay, so apply. Okay, right click and execute. So now you will see that the data is almost consistent. Jangan tengok price, tengok age ni. The range dia almost in the standard range. Okay, in the standard range. All right, so I think now is already 11:18. How about we continue this lesson tomorrow?